Good day, everybody, and thank you for tuning in to the lecture on Firefighting Foam Basics Part 1. I am Rahul Patteri, and I've been fortunate to have contributed to around 15 years in the field of process safety and loss prevention. The primary need to present the lecture series on hashtag loss prevention maverick is to reach out to the aspirants out there, and in addition to that, to provide free, accessible and easily comprehensible content on HSE matters. A little bit about myself. I started my career as a firefighter where I picked up the tools and techniques on firefighting, survival, and from there on moved into onshore and offshore EPC companies where primarily it was about writing of specifications, safety requirement specifications, fire water demand calculations and hazardous area classifications and flare radiation modelings and all that. From there on, moved into process safety consultancy. So here it was about facilitating workshops like hazards and hazards, performing assessments like QRAs and FRAs, and documenting coma process, writing up emergency response plans, reliability assessments, performance standards, bow ties, and all that. From there on, moved into an oil and gas operator wherein was responsible for greenfield and brownfield projects for the value assurance process it was called, and towards the operations was looking into the risk management of the same, rig movement, chopper operations, ship collision studies, temporary refuge assessments, etc. And presently now I work with an onshore refinery and petrochemical complex exercising the authority having jurisdiction for loss prevention. Now, where can the firefighting foam be used? So as the name suggests, it is for fighting fires, of course. So it can be used for spill fires by created during aircraft crashes and also for industrial spill fires. The difference, however, is here for aircraft crash, it's primarily life safety. So the foam should be a rapid knock-on and therefore give time for personnel to escape. Whereas for industrial spill fires, it is to avoid the escalations and primarily concentrated to asset safety. These firefighting foams can also be used for tank fires. The very recent one right now was the Port Dickinson Rimseel fire, and we also know of the much renowned Bunsfield. Firefighting foams are used for road and rail fires as well. It can also be used for the marine environments, for jetties and oil tankers, and as well as for aircraft hangars and for helidecks. Over the part 1 lecture series, we will look into the following terminologies like what is foam concentrate, what's a foam solution, what is foam, or rather finished foam, what's a non-aspirated aspirated foam, the various expansion classifications, CAF, SEFS, how foam works, the various expansions of foams, limitations of foam, and foam application methods. So what is a foam concentrate? It is a dense formulation stored on containers. It could be on totes of 1,000 liters. It could be on wheels so that it can be mobile and helps in logistics. So when this is proportioned on certain predetermined percentages, it has this innate ability to knock out fires. Foam concentrate when mixed with water is called the foam solution, and this foam solution when gets mixed with air, we get something called as foam or the finished foam. The NFPA definition for foam is a stable aggregation of small bubbles of lower density than oil or water that exhibits a tenacity for covering horizontal surfaces. So as you see, if 3 liters of foam concentrate is mixed with 97 liters of water, goes on to take in 900 liters of air, we get 1000 liters of finished foam or foam. So now to calculate the expansion ratio, we take the 1000 liters of finished form of foam divided by 100 liters of foam solution, which gives us 10:1 expansion. Now let's look at the various expansion classifications of foam, so which is low expansion, medium and high expansion. So low is up to 20:1, medium from 20 to 200:1 and high from 200 to 1000:1. So how does the foam work? So most of us would be familiar with the fire triangle, the oxygen, heat and fuel. So when one of those are eliminated, so we can knock out fire. So when foam, what foam does is, as foam is generated, it sort of flows in and it separates the fuel. So it starves the fuel, it smothers, so therefore it avoids oxygen interaction, and it cools down and therefore removes heat. So what is the performance characteristics that we need from firefighting foam? Let's look at it one by one. So from foam, we need it to form tough, cohesive blanket. And the film so formed should be able to suppress flammable vapors. It should hold enough water content. A property as in where in the soapy solution, the quarter of a soapy solution drains from water is called 25% of a drainage time. It has to flow freely, and while flowing it should be resistant to picking up the flammable fluid. It should be heat resistant, and it should be able to go on and sneak and form a seal not only on the fluid surface but also onto this hot metal surfaces. And then it should have good burn back resistance. So the next definition that we are going to go through is CAF. It's called a compressed air foam. So what it entails, as the name suggests, when the foam concentrate and water supply is proportion to form a solution, and a chamber, compressed air or nitrogen is mixed, and that gives us CAF, a compressed air foam. So let's see a typical unit. So over here it is the foam solution by the bottles which are black. So by code it should be nitrogen. So once it is delivered from the nozzle over here, you see it produces something called as a dense and cohesive foam. On the next slide, when you see people using their, look at the type of the foam from the hand lines as the foam is released. Look at them stick onto these surfaces. So that's what in CAF, it gives you pretty sticky cohesive foam. The next one which we are looking into is SEFS, so it's called a self-expanding foam system. So just like CAF, and here the name suggests, over here it is a foam premix and it's in a pressurized container, mostly with CO2. So and then on detection there would be an isolation valve over here, and that gets a signal to open, and the solution, the foam mixed with CO2, and if you see the bubbles, the two phase, it flows out, and as it comes out, the CO2 or any other inert gas, it sort of flashes, and this particular flashing aspirates, so it picks up air, and then foam bubbles or finished foam is formed. This is a typical structure, just like a pressurized container and then the related pipe work. And here is the sort of a test prototype of the SEFS being generated. Don't kill the messenger. I do not take accountability for the safety of these observers. Now let's move on to the portion called the limitations of foam. Yes, foam will not work with water reactive materials. Yes, I mean, if you could recall, we saw that one of the performance characteristics for foam is for that to form a cohesive blanket on top of the fuel surface. So with a water reactive material, it cannot be applicable. The next is that it cannot be used for 3D running fuel fire. So if you see over here, to me it sort of seems, I've taken this from internet, that a tank on fire and the tank wall has buckled because of some integrity issues, and then the fire seems to be falling down. So for such types of running fuel fires, we cannot apply foam, and here as well. Why? Because for such foam needs a stable surface where it has to form a stable foam bubble. Likewise, if you see, it cannot be used for jet fires. For a jet fires like this, even if you apply foam, it will just fall in and it will not be able to form a blanket or suppress the flammable vapors. Even for low pressure driven fires, if you see this teeny weeny fire over here, it is propelled by the hydraulic head of this fluid. So even because of this head, the teeny weeny pressure that it has, possibly unless we sort of tactically apply a surface and flow back, it will not be able to extinguish the fire effectively. So now, what are the various foam application methods? It can be by using handheld equipment, if you see the person using it. With my experience in firefighting, this is not one of the best stances. He can possibly lean in a bit forward so that he'll be able to stabilize his body weight. Possibly tactics can be another part of a video. It can be also by monitors, by foam sprinkler, spray and deluge systems, foam pourers as you see over here, fixed pourer systems, and by subsurface or semi-subsurface by using the high pressure foam generators. And this brings us to the end of part 1 of the firefighting foam series. Image credits, yes, I've taken a lot of this from Google. A few of them have also been from some last fire webinar reports. This is a video of mine on QRA, and for those who have not seen it, can please go check it out. From the remarks that I have on the video of QRA, it is that it's pretty rustic, but then it also gives some insight about what is QRA and what are the factors affecting QRA. So as part of the lecture series henceforth, I would be honoring people who have helped me with my life and my career, and who better than my parents. So in Sanatana Dharma, they say Mata Pita. In the words of Abraham Lincoln, who said that all that I am and I ever hope to be is because of my mother. In my case, it's because of my mother and my father. They were supposed to be here to spend time with us, but due to this COVID situation, they are back home in India, Kerala, hearty and healthy. Stay tuned for part 2 and more parts on this firefighting foam. Thank you very much for listening.